Hi all, and welcome to our lecture on lists. As a reminder, you do have pre-lecture readings that you are supposed to do before going through this lecture material. I will cover some of the information in those readings, but not all of the information in those readings. Instead, we're more focused on applying the knowledge that we gain from those readings into practical examples. So at a very, very high level, lists are just a concise way of referring to a lot of data. So the example we gave in the textbook was a grocery list where you might have different items that you need to pick up from the grocery store. You can add to that list as you think of new items that you need. You can remove things from that list by crossing them out as either you find them at the grocery store or maybe you don't need them anymore, different things like that. Lists are a way for us to do that within programming itself. So we need to know how to do all of these different things with lists. We go over how to do all of these different things with lists in the reading. So it's a good opportunity for you right now to pause the video, go through those different bullet points and think, can I do this? Do I remember this information from the readings? I will actually not go over how to do this. There is a solution in the solution posted in the learning resources for this week, so you can fact check yours to see if you got the right syntax there. And also it's a good way to kind of gut check, how is this going? Did I retain that information? Am I struggling with any of this? If the answer to those things is yes, I'm kind of struggling, no, I didn't quite understand that syntax, it's a really good indication that you should stop by help hours or the lab. Ask us some questions. We can help walk through what that syntax is, help you figure out what the roadblock that you're having is, and get you more comfortable working with lists. All right, so for exercise 1 here, we are given a list called My List. We know it's a list because it has square brackets and a bunch of items within those square brackets that are corresponding to the list. And the first question we're asked is, what is the length of this list? Now, when I was starting out, how I would do this is I probably would have just went through and counted all the commas, been like 1, 2, 3, 4, 5, 6, and then added 1 to that because we're always off by 1 in terms of the number commas that we have in the size of the list. So I would have been like, oh yeah, that's probably 7 items, and moved on with my life. But that would be incorrect. And the reason that it's incorrect is because in this list at offset 3, which remember, computer scientists start counting at 0, so offset 3 is actually the 4th element in that list. It is a list itself. So lists can contain any kind of data. They can contain numbers, integers, floats, strings, Boolean. They can also contain other lists. And they often do, because usually we are storing lists upon lists that contain other things and all sorts of different things like that. But when they do, if we just do that kind of naive method of counting commas, and then adding 1 to it to figure out the size, that can be really misleading. We actually need to go in and take a look and figure out, okay, what elements and what offsets do we have? So for offset 0, we have a value of 1, offset 1 is a value of 2, offset 2 is a value of 3, and then offset 4 here is this sublist. So that's both of those different items in that sublist are contained at offset 3. Offset 4 is the value of 42, and offset 5 is the value of 47. So since we have 5 offsets, the length of the list is actually 6 in this case. And so if we did something like len my list in Python, and my list was defined as it was up there, we would get a value of 6. For B, we can say we get the number 47 by saying my list 5, because remember this has an offset of 5 or an index of 5. You'll hear those words interchangeably in programming. But what other value could we use for X to also give that 47? And so the key trick here is that we can actually use the offset -1 to get the very last element in the list. And that's often a trick that we will use in Python to get that last element. So that's a handy and nifty one for us to use. Our next question here is we have what value of X, when we say my list X, would give that sublist that says hello there. And so again, if we start counting at 0, 1, 2, 3, it should be my list with a value of 3 to get hello there. And of course you can print this out in PyCharm if you want to convince yourself that that is actually the case. Then to access the element hello, we need to do the same thing that we did in question C there. So my list 3, but then because that is returning a list, we can also add another set of square brackets there to index the individual elements of that sublist. So since we want hello, that is at offset 0 of that sublist there. So effectively what we're doing is the computer will look at this part first and it will say, okay, what's at my list 3, which is this list that we get here. It will then take that list and then index it at 0, which will give us the hello. Finally, our last question is using slicing and lists appends on my list. How could we get the list 1, 2, and 47? So this will be a multi-step solution, which, here, let me just move it over here. I guess we could expect, given that the question is saying using slicing and appends, how would we do this? So the very first thing that I would do is I would get that first sublist of 1 and 2 out of my list, store it in a different variable using a slice. So I could do something like my list 2, and then a slice, remember, is by saying something like my list, and then square brackets, and giving it the indices that we would like to take out of that list and put into something else. And so remember, they're inclusive on the lower end of that range, exclusive on the upper end of that range. So you always want to go one offset further than what you actually want, similar to what we saw with range. And we just use inside of our square brackets the starting offset that we want, followed by the offset 1 further than what we want. So let me just double check, 0, 1, 2. Let me actually swap this to 2 here. So that will give us a list containing 1 and 2. We can then add to that list. So going my list 2 dot append, and we can add the very last index in my list to that. So my list -1 to give us that 47. We could also just replace this whole thing here with the value 47 if we wanted to. That's okay as well. There's lots of different ways that we could go about doing that, but if we just wanted to use my list values and then the slicing and appending, that is how we would get that done. All right, for exercise 2 here, we have 2 lists. One is called list 1, and it has the values 1, 2, 3, and the other one is called list 2, and it has the values 4, 5, 6. So what I would recommend doing, I'll probably just write the responses in the slide to keep it simpler. I would recommend you typing those lists out in PyCharm and then trying to code along with me and printing out the results. So even for things like we did here, instead of just seeing this on the screen and taking my word for it, go into PyCharm, write out this my list that we have for exercise 1, and then add some print statements around these things and print them out to see if you get those values that I said you would. Don't trust me. A little bit of healthy skepticism never hurt anyone, right? So print those out, make sure you're getting those values that you expect. Do the same for this exercise 2 as we're going along. So type out that list 1 value, type out that list 2 value, and then as we're going through these things, print out the results of what I'm walking you through to ensure that, yes, they are actually doing what we expect. Or, hey, how about instead of me saying you do those things, I just do them with you? Sure, why not? Okay, let me make a new file here. Python file, chapter 15, exercise 2, and let me type those out. So list 1 was 1, 2, 3. List 2 was 4, 5, 6. I've got the assignment symbol. There we go. And then, so our very first one that we want is we want a list that looks like this. 1, 2, 3, 4, 5, 6. Let me add in all of these just so I don't forget. Then we want one that looks like this. 1, 2, 3 with a sublist 4, 5, 6. And then we want 1, 2, 4, 5, 6, 3, 4. I think that's all the ones we need to do here. Yeah. So we're only using appending, indexing, and slicing in order to do this. So the very first one I would say is relatively easy, and let's just print them out instead of storing them in different variables this time. So to do that, we just do list 1 plus list 2. If I could type. And we hit run, and you'll see we get the value that we wanted there. So that list 1, 2, 3, 4, 5, 6. For the next one, we want the second list to be a sublist within the first list. So when we see that sublist, oftentimes that means we're going to want to be appending something. So we would do list 1, append, list 2. And that will add in list 2 as a sublist into list 1. And I know it's really easy for me to look at that and see, oh, and look at this, I get none. That's because I got to do this before. See, I pretend like I know everything sometimes, but then I make silly, goofy mistakes like this. Let's go like this, copy this out here, paste this out here. We're modifying that list, and then we can print it out here. Because there's not actually anything returned by that method append. It is just an operation that will happen on that list. It modifies list 1 for us, does a whole bunch of code that we don't have to write, and then we can print out to see the new value of list 1, which we see right there. And then for our final one, it's going to be a little bit different than the other two that we've seen. So we're going to have to do some slicing. I'm going to also comment out this slide here that we just did, because otherwise it's going to use that modified list 1, which is going to cause all sorts of problems for us. So we need to slice out some different values, and then we are also going to be appending to get some sublists, and then adding in some other values there. So I'm first going to make a temp list, and I'm going to, or maybe I'll call this, oopsie, new list, because I'm so creative. And I'm going to slice out the first 2 indices or offsets of list 1. So remember how I do that is I go and I put list 1, square brackets. Inside those square brackets, I specify the starting offset I want, and then 1 past the ending offset that I want. And we can just convince ourselves that that's working by printing that new list out. That should give us the values 1 and 2, which would be the very first things that we want in our new list. Now that we have that, we can append to that list to get this sublist of 4, 5, 6 by appending list 2. And then we can also print out new list again. And if I run that, you'll see I get 1, 2, and then my sublist of 4, 5, 6. My next step here will be to append 3, because that will come from list 1, and then I will append 4, which will come from list 2. So in order to do that, we'll do new list append list 1, and I'll get the last index or the last element in list 1 using that -1. Then I'll do another new list dot append, and I'll do list 2 and get the very first value in list 2. And then I will print out my new list to prove that this worked as expected to both yourself and to me. And we can see we get the list that we expected with the 1, the 2, 4, 5, 6, 3, and 4, which is exactly what we wanted from those slides. Hooray. See, sometimes I know what I'm doing. So for exercise 3, we are going to be doing similar types of operations, but with strings. So many of the different operations that we went through with lists can also be applied to strings, because strings are just an ordered sequence of characters, which also means that we can apply them to things like our sequence variables, etc., etc. So we have the following string, which is pseudo hypoparathyroidism, lovely, stored in a variable called myString. We want to get, or we could get the string capital POP by using the expression string at offset 0 and plus myString at the slice between 5 and 7. So that would give us that capital P and then the OP from the offset 5 and 6. Similarly, we want to use myString in indexing to get the following. So the string sud. How would we go about doing that? Well, what we need to do is find where we can get those characters within that string that we already have. So there's lots of different places in here where we could choose. I'm going to choose this S, this U, and this D. And so what I need to do is count out where those offsets are. So I'm at 0, 1, 2, 3. That's a 3. And a 4. It's trying to make my writing prettier using AI or something, and it's just causing me problems. So now that I have those, I can write similar kinds of expressions. So I would go my string 1 plus my string 3, and then we slice it to 5, because remember our slicing goes is not inclusive on the upper bound, so we always have to go one past where we want, and then that would give us the value. The only reason I'm not doing this in PyCharm is because I don't want to have to type out pseudo hypoparathyroidism. It will take me hours. You all have seen my typing and my spelling throughout this term. It's not great. I'm not going to put you through that. So I recommend you doing something similar on your own. Next, we want the same string as myString, but with the first and last 3 symbols removed. So in this case, what they mean by that is the characters. So the first 3 characters removed and the last 3 characters removed. And so we can do that again with slicing. And so all we need to do here is figure out where those slices need to start. So for myString, our first slice index will be easy because it will actually start at 3, because that will be our 4th character. Because remember, computer scientists start counting at 0, so 3 is actually the 4th character when we talk about offsets. And then to get the last, we need to get the length of the string minus 3. So we just put len, and then we can put myString. So this is a whole bunch of nesting craziness going on here, but the computer will effectively calculate this first, figure out what the length of that string is, and then we can have an expression that says minus 3 to get the last 3 characters removed off of that, and then finish off our slice there. So this looks a little bit messy, but remember the computer is okay with things looking a little bit messy to humans because this makes perfect sense to the computer. What it does is it says, okay, I'm going to take my string, I'm going to do a slice, I'll start at the 3rd offset, and then when it's trying to figure out what that last offset will be, it will actually evaluate that whole section that we have in there to figure out what that number will be. So it will get the length of the string, it will subtract 3, and then it will use that to figure out what that last offset should be. To reverse the string totally, this is a bit of a trick. I don't think we went over this in the textbook, so we'll do it here. You again use the same kind of slicing notation, but what you do is you do colon, minus 1, and that will actually reverse the string for you. So effectively, it's telling the computer to start at the end, and then it goes to the beginning, just reverses everything out for you. So that's just a little bit of syntax that you'll probably want to memorize. And then we also have the reversal of the string, but skipping every second letter. So the string will begin with M. And so the way to do this is slightly different than what we saw up there. So this offset of a minus 1 means it's going to include every single letter. If we want to skip that, then we need to change that to a minus 2. And so what we would do here is go my string minus 2. And that will make it skip every second letter. Similarly, if we wanted it reversed and skip every fourth letter, we just do minus 4, etc., etc. So just a little bit of syntax that we didn't go over in the textbook, I don't think, for you to get familiar with there. For exercise 4, we're going to write some Python code that's going to declare a list called class list and then read in student names from standard input and put them into the list. We will then write a Python function that takes 2 parameters, a list and the length of the list, and it will read values from standard input to put into that list. So we should be able to take a lot of the code that we use in A and then just reuse it in a function for B, which will be quite nice to do. So let's go back over to PyCharm. Where's my PyCharm? Here it is. And we'll make a new file. Chapter 15. Exercise 4. And so the very first thing we're going to do is the first part of that. So part A, where we are writing Python code that reads names from standard in and puts them in a list. So first off, we're going to probably want to make a variable called class list that starts off as an empty string. This allows us, or not an empty string, sorry, an empty list. This allows us to, within a loop or some other thing, continuously append to it. If we don't tell Python that we have this empty list that's we're going to do something with, it can get a little bit messy. It might initialize it to something that mucks up our code. So we want to always say, whenever we're going to be using a list, we're going to be doing things like adding to it, we always start off with an empty list. That's like us getting a fresh piece of paper ready to write our groceries down that we want to get from the store. You know, we got to get that piece of paper first instead of like writing it on our hand and it gets like smudged or something like that. I don't know if that analogy works 100%, but you know, it works for my brain. So we're going to be reading names in from standard input. Let's just assume that for the sake of argument, we have number of students is equal to 3, just so that I don't have to run this code for a really long time in order to show that it is working. So then I can make something like a for loop for S in range 3. That will just iterate the loop 3 times. We can get inputs. So we can get name, input from the user, which we know how to do, enter the student's name, and then we can add or append that to class list. Append name. And so once this is done, we can just print out this list, class list, to show that this worked as expected. I'll also add a print for it at the beginning to show that it is actually empty when we start off. And so if we run this here, you'll see we get an empty list and then we say enter the student's name. So we'll put in Ryder, and then we'll put in Vader, and then we'll put in Rambo, which are of course the dog names. And now you'll see we get a list at the end that says Ryder, Vader, and Rambo. Part B of this was to write this as a function. Oh, and you can see I forgot to put in my comment there, so now it's yelling at me and saying I have so many errors, but I don't. The function should have 2 params. One should be the list, and the other should be the length of the list. So what we can do here is first off start by defining our function with that def keyword. We're then going to give it a name. So we could call this something like read names. And we have 2 functions. We're going to have our class list. And we're also going to have the num students for sake of argument. Then in here, all we need to do, we can take this code that we had up here, as well as our print. I'm just going to copy it down copy. There we go. Copy it down here. It's all nicely tabbed out for me. And then just make a couple of changes here. So for a range, we should put num students, which is the number that we're passing in. We're reading in that name, we're appending it to the class list, and then we're printing out the class list. And so we can, I'll just delete this code up here so it doesn't run it for right now. We can then call this function with read names. We can give it a list, and we can give it some number of students, which in this case I'll put 3. PyCharm does some really nice things. It shows us, oh, these are actually what those parameters are called for the arguments that you're passing in. If we run this, we enter our student names again, Ryder, Vader, Rambo, and we get the same list out at the end of it. Lovely. If you have questions about that, again, come to help hours. We're happy to walk through that in more detail. Oops. So for exercise 5, we are going to assume that a list is a list of 10 integers. So we're going to have a variable called list. We want to write the function header and doc string for this function here. So in this case, the function is called func. It takes in one parameter list. M is then selected as the very first element in that list and stored. Position is equal to 1. So while position is less than 10, if the current element we're at is less than the element that's stored in M, we reassign M to be that smaller element, and then we increment it by 1, and we return M at the end. So this should be a function for getting the smallest number in a list. So if I'm doing my doc string, this is going to look something like this. Returns the smallest number in a list. My param list is going to be a list of integers, and my return is going to be the smallest integer in list. And that's my doc string. And then, so I would put that, remember, that's going to go right in here. So right after our function header is where that doc string would go. I would probably also add a comment in here before this while loop that would just say something like, go through all of the elements in the list. If the current element is smaller than the last smallest we've seen, make it the new smallest, etc., etc. The question we have down here is this a robust function? It isn't. It is not. This only works for lists that have a defined size of 10. We could do so much to make this a little bit more robust, but even just making this be len of list, I'm not going to keep typing. You know what that looks like. I should have used the type instead of the draw. That would not restrict it to only being lists of size 10. It would allow it to be a lot more robust, a lot more reusable in a lot of different settings. All right, we have our next exercise. We're asked what is printed to the console by the following program. So we have a class list here. We have one variable p that starts out as a value of false. We're checking to see if the value Ernie is inside of a class list. If it is, we get the index. If it is an index that is higher than 0, then we check to see if the index before it is Bert. If it is, then it gets a value of true. If the index is less than the length of the class list -1, so it's less, not the very last element in the list, then we check to see if the element after it is Bert, and then we return true. So effectively what this program is doing is it's checking in the class list to see if Ernie is in the class, does Bert come before or after Ernie? And if it does, it will print true. Otherwise, it will print false. So remember from the textbook that we can use that in keyword to check to see if a value is stored within a list. In this case, Ernie is stored within a list and Bert does come after it. So P will get a value of true here, and a value of true will be printed by line 13. All right, let's get into some examples here with DNA. So we're going to write a function called getLength of a DNA list and a length that returns a list of the strings in DNA lists of certain length. So for example, here's two function calls. If we used getLength with these four different sequences and our length that we passed it in was 3, it should return all sequences in that list that are length 3, which it does. And the second one here, we have 1, 2, 3 sequences. We want all sequences in that list that are length 2. There are none, so we get an empty string. So we want to go and actually write up this function. So let's go back over to PyCharm. Let's make a new Python file. Chapter 15. This is exercise. What exercise is this? 7. Okay, so first off, we'll start off with our function header. Our function header always starts off with that define keyword. Then we do our function name. We were told it needs to be called getLength. And then we also need to pass in 2 parameters. So one is called DNA list, which is a list of DNA sequences, and the other is called length, which is the length of sequences that we want to return. We then will add our docstring in. So this is going to get a sublist of sequences of length. I'll just put this in stars, just so it's different. Length. I probably wouldn't have called that length, but that's okay, because that's confusing definition. That's fine. DNA list is going to be a list of DNA sequences. Length is going to be the length of sequences we want to return. And what gets returned by this is a list of all sequences in DNA list that are of length. I hate that so much, but that's okay. And that's my docstring. Again, your docstring could look slightly different. You probably have different ways of phrasing things. That is completely fine. So what we need to do here is we need to build up a new list and then go through, this is probably spelled wrong, isn't it? Length. Also a reason why I wouldn't call it that. NG, there we go. Because I can't spell it very good. So we're going to be building up a new list. That usually means we want to start off with our fresh sheet of paper or our empty list. We then go through DNA list, check to see if the sequence at that index is less than or is equal to length. If it is, then we add it onto that list. So I'm going to make a very fancy variable called new list, very creative name. And then I'm going to loop through all the sequences in DNA list. So I can do for seq in DNA list. And then I just check to see if it's equal to length. If length seq is equal to length, then we will, oh, I did way too many equals there. Just one, but that's okay. If it is, then we're going to append it to new list. And after all of that, we just return new list. And of course, we want to double check that this actually works. So we will call it, and we will just print the results to make it easy for us to check, get length. And our DNA list, I'm going to keep it pretty simple. Oops, I forgot to put it in square brackets. PyCharm is trying to be creative and help me, but it's not. We'll do another G. And I'll do one that's 3, sir, ATG, or ATC, why not? And then let's just test this with the value of 1. We should get A and G added into our new list that gets returned. And I'm missing one positional argument length because I accidentally have a bracket there that is not needed, and that was confusing my computer. And then I have another bracket where something wasn't closed. Let me see. Oh, I see what happened. That bracket was supposed to be on the outside there. Just a couple syntax errors. And now when we run that, we do get A and G. If I put something like 4 in, we should get an empty list, which we do. And if I put something like 3 in, we should just get that one sequence ATC, which I do. Hooray, it works as expected. We love that for us. So exercise 8 here is a very similar type of problem. So the police are working on a case. The suspect's first name starts with a J and works with a Michael Thornton. We want to write a function called find suspects, which takes in a list parameter employees and returns another list containing possible suspects. The employees is a list of strings, and each string is in first name, last name format. If there's no one named Michael Thornton in the list, then no one would be a suspect. Otherwise, if there's any names in the list that start with the letter J, they would be a suspect, and we should return that as part of our list of possible suspects. Remember that we can index strings in the same way that we index lists, and this would give us some example output that we would see here. I actually want you to try to do this on your own using all the examples we already went through, all of the content that is in the readings, and see if you can get a solution to this. You can check your solution based off the one that is in or posted in the weekly learning resources. And if you have any problems, you know how to get help. Help hours, discussion board, etc., etc. We are here to help. Best of luck.